Welcome to our exploration of the ozone layer, protecting our planet. The ozone layer is an unseen guardian, a vital component of Earth's atmospheric shield. It plays a crucial role in protecting all life forms by absorbing the sun's harmful ultraviolet radiation. Without it, life as we know it would face significant challenges. The ozone layer's importance cannot be overstated. It is key to maintaining the delicate balance required for life on Earth. In this piece, we'll discuss the atmosphere's structure and the specific role the ozone layer plays. We'll also examine the severe consequences of its depletion due to human activities and the international efforts aimed at its preservation. By the end, you'll have a clear view of the steps needed to protect this essential shield. Join us on this journey as we uncover this vital aspect of our planet's defense system. Understanding the ozone layer's significance is the first step in ensuring its protection. The Earth's atmosphere is composed of several distinct layers, each serving unique roles in maintaining our planet's habitability. This gaseous envelope is primarily made up of nitrogen and oxygen, with trace amounts of other gases, including the all-important ozone. The atmosphere is structured into 5 main layers based on temperature variations, and each layer provides different protections and functions. The lowest layer, the troposphere, is where weather phenomena occur, making it the most dynamic part of the atmosphere. Above it lies the stratosphere, home to the ozone layer, which plays a pivotal role in filtering out harmful UV radiation. Understanding these layers helps us appreciate how the atmosphere serves as a multifunctional protective shield. Each layer, with its unique characteristics, contributes to sustaining life on Earth by regulating temperature, providing breathable air, and protecting us from harmful cosmic and solar radiation. The ozone layer, nestled within the stratosphere, is crucial for blocking UV radiation, making it a vital focus of our discussion. Ozone is a molecule composed of 3 oxygen atoms, denoted chemically as O3. It forms naturally in the stratosphere through a process involving ultraviolet radiation from the sun. When UV light strikes oxygen molecules, they split into individual oxygen atoms. These free atoms then combine with oxygen molecules to form ozone. This dynamic cycle of formation and destruction is continuous, maintaining the delicate balance of ozone concentration in the atmosphere. The presence of ozone in the stratosphere is essential for life on Earth. Its primary function is to absorb the majority of the sun's harmful UVB radiation. Without this protective layer, the surface of our planet would be exposed to higher levels of UV radiation, leading to severe consequences for ecosystems and human health. The ozone layer thus acts as a shield, mitigating the impact of UV rays that can lead to skin cancer, cataracts, and immune system suppression. While the formation of ozone is a natural process, it is subject to disruption by human activities. The ozone layer functions as Earth's sunscreen, effectively blocking the majority of the sun's harmful UVB radiation. This protective barrier is crucial for preventing a variety of health issues in humans, including skin cancer and cataracts. Additionally, it plays a significant role in preserving the health of ecosystems both on land and in water. By absorbing UVB radiation, the ozone layer helps maintain the integrity of food chains and biodiversity. In addition to protecting health, the ozone layer influences climatic patterns. It helps regulate the temperature of the stratosphere, which in turn affects weather and climate systems below. The role of the ozone layer extends to the protection of materials and structures on Earth. By filtering out harmful rays, the ozone layer reduces the rate of such deterioration, indirectly supporting economic and infrastructural longevity. The multifaceted protective roles of the ozone layer make it an indispensable component of our planet's environmental health. Section 5. Consequences of ozone layer depletion. Ozone layer depletion refers to the thinning of this vital atmospheric layer, primarily due to human-made chemicals like chlorofluorocarbons or CFCs. The breakdown of ozone molecules allows more UVB radiation to reach the Earth's surface, resulting in a host of adverse effects. Increased UV exposure leads to higher incidences of skin cancer and cataracts in humans, posing serious public health challenges. The impact of ozone depletion extends beyond human health, affecting ecosystems and the environment at large. For instance, excessive UV radiation can impair phytoplankton, the foundational organisms in marine food chains, leading to disruptions in aquatic ecosystems. Terrestrial plant life also suffers with reduced growth and productivity, which could lead to broader ecological imbalances. Moreover, ozone depletion has potential implications for climate change. Understanding the broad and interconnected consequences of ozone layer depletion highlights the urgency of addressing this environmental issue. Section 6. Human influence ozone layer depletion. The depletion of the ozone layer is largely attributed to human activities, particularly the release of ozone-depleting substances such as chlorofluorocarbons, halons, and other related chemicals. These compounds, once released into the atmosphere, rise to the stratosphere, where UV radiation causes them to release chlorine and bromine atoms. These atoms then engage in chemical reactions that destroy ozone molecules, leading to the thinning of the ozone layer. The use of CFCs in refrigeration, air conditioning, foam production, and aerosol propellants was widespread throughout the mid-20th century, significantly contributing to ozone depletion. Despite their useful properties, the environmental cost of these chemicals was not fully understood until their detrimental impact on the ozone layer became evident. The so-called ozone hole, first observed over Antarctica, provided tangible proof of the damage caused by these substances. In addition to CFCs, other industrial processes and agricultural practices contribute to ozone depletion. Recognizing the human influence on ozone layer depletion is essential for implementing effective strategies to mitigate this issue. Section 7. The Montreal Protocol, a global solution. The Montreal Protocol stands as a testament to the power of international cooperation in addressing environmental issues. Adopted in 1987, this landmark agreement aimed to phase out the production and consumption of ozone-depleting substances. It has been remarkably successful, with all UN member states committing to its goals, leading to a significant reduction in the release of harmful chemicals into the atmosphere. One of the key features of the Montreal Protocol is its dynamic approach, which allows for adjustments and amendments based on scientific advancements and environmental needs. This flexibility has enabled the treaty to incorporate new findings and address emerging substances that could threaten the ozone layer. The success of the Montreal Protocol is evident in the predicted recovery of the ozone layer. If current trends continue, scientists expect it to return to pre-1980 levels by the middle of the 21st century. The Montreal Protocol's achievements underscore the importance of international agreements in tackling global environmental challenges. Section 8. Individual actions for ozone protection. While international agreements like the Montreal Protocol play a critical role in protecting the ozone layer, individual actions are equally important. Each person can contribute to the preservation of this essential atmospheric component by making informed choices and adopting sustainable practices. Awareness and education about ozone-depleting substances and their effects are crucial steps toward fostering responsible behavior. One simple yet effective action individuals can take is to choose products that are labeled as ozone-friendly. Many household and industrial products now offer alternatives that do not rely on harmful chemicals, such as CFC-free refrigerants and aerosol propellants. By supporting these products, consumers can drive market demand towards more sustainable options. Educating others and advocating for policies that support ozone layer protection can amplify individual efforts. Section 9. Conclusion. Our role in ozone protection. In conclusion, the ozone layer is a vital component of Earth's atmospheric shield, crucial for protecting life from harmful ultraviolet radiation. Human activities have posed significant threats to this natural protector, but through international cooperation and individual efforts, we can mitigate these impacts. The success of the Montreal Protocol highlights the power of global collaboration in addressing environmental challenges, setting a precedent for tackling other pressing issues like climate change. The path to ozone layer recovery is a testament to the positive outcomes that result from informed action and policy implementation. Each individual has a role to play in ensuring the continued protection of the ozone layer, from making conscious consumer choices to advocating for sustainable practices. As we move forward, let us remain vigilant and committed to safeguarding the ozone layer. By doing so, we not only protect our planet, but also ensure a healthier, more sustainable future for generations to come.